right, so this is just an example of how we can apply what we just learned about the trapezoid rule into one of the AP free response questions. So this one is from 2005, which happens to be the year that Ms. Schwartz graduated from high school. So this is actually my AP calculus exam. It says a metal wire of length 8 centimeters is heated at one end. The table above gives selected values of the temperature T in degrees Celsius of the wire X centimeters from the heated end. The function T is decreasing. So if T is decreasing, we can identify that T prime is negative. And twice differentiable, which just implies that T double prime, if we need it, exists. So let's think about the logic of the question, right? So distance from the end. So we're being heated at 0 centimeters, and we've got this hot temperature of 100 degrees Celsius. But as you move down the length of the wire, the temperature gets cooler, right? So if you think about a heat source being on one end of a wire, it's going to be pretty hot. And then as you move further away from the heat source, that wire is not quite as warm. Estimate T prime of 7. Well, T prime of 7 would represent the rate of change at 7. We can't find the rate of change specifically at 7, but we could approximate it by saying what's going on around 7, right? So we can use our old school slope, indicate units of measure. So old school slope is going to be 55 minus 62 over 8 minus 6. So we end up with negative 7 over 2. The numerator, 55 and 62, were measured in degrees Celsius. The denominator, 8 and 6, were measured in centimeters. So our units are negative 7/2 degrees Celsius per centimeter. So the rate of change of the temperature at time 7 is approximately negative 7/2 degrees Celsius per centimeter. All right, that doesn't have to do a trapezoid rule yet, so let's look at the trapezoid rule. Write an integral expression in terms of T for the average temperature of the wire. Average temperature of the wire. Then estimate the average temperature of the wire using a trapezoidal sum with the 4 subintervals indicated by the data in the table indicate units of measure. Well, the first thing is we need an integral expression. And if we want to find the average something, right, we do our 1 over b minus a. The integral from 0 to 8, t of x dx. So you could leave it like this, or of course you could rewrite it as 1/8 the integral 0 to 8 t of x dx. Okay, so we fit the first criteria. We wrote the integral expression. Then it says we're supposed to estimate the average expression using a trapezoidal sum. So what we're going to do is we're going to figure out an approximation for this integral using the trapezoidal sum. Well, we're used to doing left-hand rule plus right-hand rule divided by 2. And that's going to be the same thing that we do here. So up at the table at the top, your left-hand rule is going to be a width of 1 times 100. So left-hand rule is going to be, come on, pen, width of 1 times a height of 100, because that's my left hand, plus a width of 4, 5 minus 1 is 4, and a height of 93. So plus 4 times 93, plus, keep scrolling, 1 times 70, and 2 times 62. So 1 times 70 plus 2 times 62. So we'll get that left-hand rule in just a second. I'll bring up the calculator. Right-hand rule is going to be, remember, these ones are going to repeat, but I'll show you. Right-hand rule, we're going to have a 1, but 93, a 4, but 70, a 1, but 62, and a 2, but 55. Okay? So we're going to have a 1 times 93 plus a 4 times 70 plus a 1 times 62 plus a 2 times, what did I say, 55. All right, so my left-hand rule, if I go ahead and add all of these up, I get 100 plus 4 times 93 plus 70 plus 2 times 62. There's my right-hand rule. My left-hand rule gives me an approximation of 666. My function was decreasing, right? So think about it for over and under estimates. Then I get 1 times 93 is just 93. I can do that one in my head. Plus 4 times 70 is 280, but I'll just type it in. Plus 62 plus 2 times 55. My right-hand rule is 545. Makes sense it's a little bit lower because my function was decreasing. Right-hand rule is going to underestimate 545. So right-hand rule a little bit too low, 545. The trapezoidal rule then, remember we're going to take our left-hand rule, which is 666, plus our right-hand rule, which is 545, and we are going to divide that by 2. So 666 plus 545 divided by 2 is 605.5. And that would end up being degrees Celsius times inches. Well, that doesn't make sense, right? But we have temperature from the T of X up here, and then and then inches by dx, and that doesn't make sense. And how can 605.5 degrees Celsius times inches be the average temperature of the wire? Oh, I forgot to multiply by this 1/8, right? We don't want to forget that that's what we're actually finding is 1/8 times all of this. So if I divide that guy by 8, the average temperature of the wire is going to be 75.688, and then because this would have been inches cancels out, and we're talking about degrees Celsius, which makes sense, right? If you look up at your original table of data, the average temperature over that interval being about 75 is logical, right? Having been average temperature of 605, no, right? Doesn't make sense within the context of the problem. So estimate the average temperature, we've got the correct units. Great. These last two don't have to do with the trapezoid rule, but I'm going to leave them up here if you would like to try them. So find the integral from 0 to 8 of t prime. So think about using the fundamental theorem of calculus, part 1. Explain the meaning in terms of the temperature of the wire. And then part D, are the data in the table consistent with the assertion that the second derivative is positive? Okay, well, second derivative positive means that t prime must have been increasing. Okay, so you want to check, is t prime increasing? Think about how you could do that. All right, those are optional though if you just want to try them. Here is, that's my work from last year. Here's the answer key. We would have gotten 4 points for what we did. We did well on those first ones. Here is the explanation for C and D. D is a little bit tricky. I'm happy to talk you through that one at a PLT sometime if you want to. Remember, part D on a free response tends to be kind of out of left field, and that is true for this one as well, okay? But that would be our in-class example of the trapezoid rule within AP context.